Well, hello. Welcome back. Pressing on in Chapter 13 today, 13.2, a little bit more with solving quadratic equations. Now, these type will be in this form, where something is in front of x squared, and it equals a number. Okay, so this a and k are just random numbers. Here's an example. 3x squared is 18. In this case, the a is 3, the k is 18. Here's another one. In this case, the a is negative 7, the k is 10. All right, so they'll be in that form, and we're going to solve those. So let's do this one. Okay, so what we'd want to do is find the value of x, right? Okay, so first of all, if this were 3x equals 18, you would know what to do. Divide by 3, right? Okay, well, just because it's x squared, same thing. I want to divide by 3 on both sides. So I have x squared equals 6, right? Okay, I don't want x squared, I want x. So what I do is take the square root of both sides, okay? So the square root of x squared is x. We've already determined that a long time ago with our radical chapter, chapter 11, long time ago. All right, and so this then would be plus or minus radical 6. We could consider that a negative radical 6 getting squared would become a positive 6. So we do want to consider both of them. All right, so there are our two solutions. Don't give me a decimal approximation. Just make sure this is simplified. Okay? All right, let's do another example. Let's do negative 3x squared plus 7 equals 0. Okay, so I want to get that in that form where x squared equals something. So I could just subtract 7, right? Everybody see that? Okay. I want to divide by negative 3. So I get x squared is a positive 7/3, right? Okay. I don't want x squared, I want x, right? So what I need to do is take the square root of both sides. So x is equal to radical plus or minus radical 7 over radical 3. Now, there's something I learned about denominators with radical. Oh, yes, you're right, Ms. Park. You can't have a radical in the denominator. So what do we have to do here? Rationalize it. Very good. So you're going to multiply by 1 in the form of radical 3 over 3 to get this out. And so our final answer is plus or minus radical 21. I can multiply radical by radical, okay, over 3. And don't try to divide a whole number into a radical. Can't, not going to do that. So this is our final answer. Again, you might want to back it up and go through it again if you had troubles with that. Okay, so let's do A through D and make sure we've got this part. A through D. All right, so for A, I divided both sides by 2, took the square root, got plus or minus radical 10. Leave it in radical form. It's simplified, There's no perfect square factor of 10, so I'm done with that. Okay. Remember from radical chapter, if this had been radical 20, I'd want to break it to 4 by 5 and simplify it. All right. Here, I divide by 3, take the square root of both sides, so I got plus or minus radical 5 over 3, but I can't leave a radical in the denominator, so I had to rationalize it by multiplying by 1 in the form of radical 3 over radical 3. That gave me plus or minus radical 15 over 3. Over here, I divided by 4. I got m squared is 25, and so m is plus or minus 5. Don't you love it when they're perfect squares? And here I divided by 9. 0 over 9 is still 0. So if h squared is 0, h has to be 0. All right. I'm going to now do the next part. So example 3 is what we're going to look at. And this is all that we're going to do. We're not going to do the word problem, so hold on. The next form that we're going to do is in this form, okay? So the last one you had like ax squared equals k. This one you've got x plus some number in a binomial squared equals a value, okay? And I'm going to teach you how to do these. So with example 3, we've got x plus 3 quantity squared equals, oh, excuse me, I got the wrong example. Let me make sure I do the one in the book here. So minus 5, and this is equal to 9. Okay, so it's in this form where x plus or minus something in a binomial squared equals a number. All right, so let's solve this type. Well, this is easy. Something squared, I just take the square root, right? Yeah. So if I have something squared and I take the square root, doesn't that radicand come out? Sure it does. Because if I have two factors of something and I take the square root, one of them comes out. All right, and then this is plus or minus 3, right? Square root of 9 could be a negative 3 or a positive 3. All right, so I don't want x minus 5, I just want x. So what do I need to do? I need to add 5. Okay, so I have x. Now think about it. There's going to be two solutions. If x is a positive 3, 3 plus 5 is 8. If x is a negative 3 plus 5, the solution is 2. And if I plugged both of those in, I should get a true solution. If I plug in 8, 8 minus 5, 8 minus 5 would be 3. 3 squared would be 9. Square root of 9 equals square root of 9. Good. Okay. If I have 2, 2 minus 5 is a negative 3. Negative 3 getting squared is 9. And square root of 9 is 9. So both of those will work. All right, let's do example 4. Okay, so just like before, I want to take the square root of both sides. So the square root of something squared means that something comes out. And this then will be plus or minus radical 7. I don't know what square root of 7 is. It's an irrational number. So I just leave it, plus or minus radical 7. Okay, I only want to know what x is. So I'm going to subtract 2. And you can actually leave your answer in this form. Okay, you want to say the integer first and then the irrational part. So do you see what I did? I subtracted 2, so negative 2 plus radical 7, or negative 2 take away radical 7 are my two solutions, my two zeros. Now, are they always going to be in this form? Well, you may have to do one little teeny tiny extra step. And since you all are so good at factoring, I'm sure this won't be a problem. All right, let's look at example 5. Anything look familiar about this? This is a perfect square, that's a perfect square. the two square roots, 8 and x getting doubled. This is a trinomial square, you're right. So this factors into x plus 8 quantity squared, right? If I did trial and error here, I'd get x and x, 8 and 8, 2 pluses. So this is equal to that, right? Yeah, so write it like this so that it's like your other problems. And then it's just like we just did. We've got a binomial squared equals a number. So we take the square root of both sides. We get the radicand to come out. We know this is plus or minus radical 17. We subtract the 8, write it first, and we are done. Yay. All right, so let me get you to do these. Try this, E through I. Okay, this is all we'll do for today. So E through I, stop the video, do it on your own, then come back and check with my work. So for E, it was in the right form, right? So I took the square root of both sides. So the radicand came out and I got plus or minus 4. Then I added 3 to both sides. So plain old x is 3 plus or minus 4. So 3 plus 4 is 7. 3 minus 4 is negative 1. So those are my two solutions. All right, for F, it was in the right form, so I took the square root of both sides. So x plus 3 comes out, equals plus or minus radical 10. And then all I need to do is subtract the 3, and I have my two solutions. Because you can't add an integer and an irrational, so you leave it negative 3 plus or minus radical 10. All right, for G, that also was in the right form, so I took the square root of both sides. M minus 1 is plus or minus radical 5. I added 1, so 1 plus or minus radical 5 is my solution. All right, and then for H, I went ahead, as you'll look at H, I factored that trinomial into x minus 7 quantity squared. Okay, x minus 7, x minus 7. So I got it into this form, and so now I took square root of both sides. So x minus 7 comes out, equals plus or minus radical 3, and add 7 to both sides, and there's my answer. For I did the same thing. Z, that trinomial factored into z plus 11 quantity squared. So I took the square root of both sides. Z plus 11 comes out on the left. The square root of 169 is actually 13, isn't it? So positive or negative 13 are my two solutions on this side. I need to subtract 11. So a negative 11 plus 13 would be 2. Negative 11 minus 13 would be negative 24. Okay? So that's where we're going to stop. Aren't you glad? So you want to check Grin Web, see what your assignment is. Please let me know if you need to talk with me, FaceTime with me, if you need some extra help. We can do that. So I hope you're having fun afternoons. Hope you're getting out, get some fresh air, get away from those video games and TV. Make sure you're, doing chores for your parents. Maybe wash their car, do something nice for them. Declutter your closets. Do a puzzle, read a book. Just enjoy life while it's quiet and peaceful and not so much hubbub going around. So I miss you guys, and I'll talk to you soon. Bye-bye.